Let's look at different types of AI data analytics. Now we're really getting to the advanced techniques for understanding how AI can help us analyze data. And we generally have four different types of areas for data analytics. At the basic level, we have the descriptive data analytics. This is where our AI is going to summarize data and give us a description of basically what's going on. So we can have things like the AI aggregating data from different sources for us, summarizing data like the average over several different periods, or comparing certain things from related data over different periods. What we're basically getting here is like information in which describes something. Now, I still think this is best over our own data. You could use this over kind of public common data, and then you could even query a public AI system. But I really think this works best on privileged information where you basically, for instance, understand how your sales have been doing, whether certain countries are doing, well or not well, presented to you in a form that you as a human can, of course, understand. Some of these examples include just continuously monitoring operations, getting reports on different incidents and things. It can show how well risk responses are working. Yeah, incident reports, you haven't received a few of those, or, for instance, that your AI is telling you that you have things that have changed through time and have been improving. I'll give you an example of this. So in my team of internal auditors, we're given the task of understanding whether a new policy or procedure was implemented across the organization. So what do we start doing? We started collecting data. We started collecting data from various sources to understand whether the new clauses of the policy or procedure had been implemented. And we would have seen that kind of through different transactional figures that we would have gotten. And for the countries where it worked well, it was obvious. And for others, we needed to contact them, understand where there were problems. Descriptive data analytics will directly present information from various sources to you. It can also be used for data discovery to collect data from various sources and put into a single place. Our next type is diagnostic. Now, I want you to understand that each of these build on the previous type. Diagnostic, it goes and looks at past performance to really determine how and what happened. But it's going to be based on an idea of the description, the summarized data, the aggregated data that came from our descriptive data analytics. I want you to understand for diagnostic data analytics that this is where AI excels. It's extremely good at understanding patterns in information. It's really good at understanding. And so when it is looking at this past performance and determining what has happened and why, it'll be able to detect things that are slightly off the norm in a way that would take humans a lot of time, right? So events and performance can be interpreted in diagnostic analytics, for instance, to understand underlying trends and go one deeper and try to understand why those underlying trends are happening or how they can influence us. Those are further steps. Analyze cause and effect. So some of our tools, for instance, are correlations that can be calculated, standard deviations, in any case, different statistical techniques to understand and analyze the data to understand why something might lead to something else. Knowing that correlation doesn't mean causation, and so you have to really dig into the explanations and the reasons why something works. But data analytics can get into that. You find out what happened or caused a certain risk event. Why did we have bad economic performance in the past economic quarter on the level of this country, I'm guessing, right? And you can dig down to understand why. You can do it to understand how things move together. Baby powder is correlated to infant milk because the same parent is going to have those two products on their shopping list. Examples of uses include things like looking for the root cause of different things, but it couldn't be a fraud incident. It could be drilling down. Okay, so this is interesting. A drilling down is where you start at a high level and you're getting into something which is increasingly detailed, focused on a particular point. You know how in the Pareto principle we have 20% of causes explain 80% of outcomes? It's useful. So let's try to understand why we had bad economic performance in the past quarter. And it doesn't seem to be like a big economic thing, okay? But we have all of our sales figures. Sales are down 25%. That's a problem. But in certain countries where it's been worse. So what happened in China? Minus 60%? Something's really bad there. So we drill down into China. And we see that, it's not every single market. It's just in Beijing. Okay, we drill down into Beijing and we try to understand it's not every single product. It's only certain product linked to, let's call it infant products. And maybe we look through the causes. Okay, now we understand that there was a regulatory thing that came up, better regulation, changed our sales in this product. And maybe this single cause might only explain, say, 15% of our 25% dip. But we've drilled down to the main causes. We might see 5% is also linked to worse sales in the US and 5% in New Zealand, making this stuff up. But I'm just saying that you can drill down to get more information from aggregate information. And AI is particularly good at that as long as it has sufficient data on all of these different things. It can really go into detail as to the causes. Using data mining to identify suspicious patterns or relationships. Now, this used to be a pretty manual thing, but now AI is so good at detecting information patterns, differences, anomalies, that we can use AI to drill down into data to identify things that would not follow the usual patterns or the usual relationships. Usually people use more umbrellas when it's rainy, but it seems we got the weather data and people aren't using umbrellas this year. There's a reason behind it, no doubt, right? We are now going into the third type of data analytics, which is predictive, is based on the diagnostics and also the descriptive. What do we see in predictive? Basically, it uses the past data to go one step further and try to analyze how the future trends might be. Now, some of these might be relatively predictable, such as demographics is the future, right? Unless you have a great shock, you can expect demographics to tell you about your future. Okay, our population is aging, and so we're going to need more healthcare products for this aging population. I mean, it's not that difficult in this case, but of course, predictive analytics can go on to less obvious relationships and try to understand current trends. And this is interesting. So usually you would take past data to understand a trend, but you might also know some things about a future situation. So say you're trying to guess future sales of houses in a marketplace. Past trends have shown that market data has been pretty good. It's been increasing 5% a year, and it's been pretty good on sales, and housing prices have also been increasing steadily. But you now know that inflation has been high. It's going to lead to higher interest rates. And so that is a characteristic that you know about the future. Maybe your central bank has announced rate hikes in the near future. And so you know that characteristic, and you will be able to feed it into the system so that it takes that trend modified with that bit of information. Okay, so for instance, I gave the example about demographics is the future. We can plan some of that. But say we now know that there's going to be a new law about immigration for skilled workers in a certain domain. We can make better analysis knowing that new information while following the general trend. Forecast changes based on interdependencies and correlations. Basically, we understand that there are certain interdependencies. We know that housing prices, the price of loans and financing is going to be correlated with a future or even current sales of houses, of apartments, of potentially offices. And so we can make a kind of prediction based on those correlations. Things that move together are correlations. We can use statistical models and machine learning techniques, which is basically where we're going to use different statistical techniques. So we've seen some of these. Standard deviation is how things move together. Regression is, well, indeed, how a certain variable changes because other variables have changed. Anyway, statistical techniques that we can use machine learning techniques on to really understand where we're going towards. Example of uses including the demographic data that I told you about to foresee long-term changes in sales patterns, or identifying products whose sales are correlated, and we know some things about one product, we might be able to correlate it with another product. Based on the predictive, we can even go one step further, and that is our prescriptive AI data analytics. And this is where you have to be a little bit careful with your AI, because you do not want your AI giving you hints or options without really understanding the reasons why your AI is giving you those choices. And it's not even real choices in every single case. We're living in a world where we have, trading algorithms, stock market trading algorithms that cannot wait for our human inputs. We're too slow. So it is going to look at certain characteristics and act automatically. But we can either get options for what it can do, and we can seek decision options on how to take advantage of future opportunities and mitigate future risks. But we need to be careful about why is the AI suggesting these things to us, or show the implications of different decision options. Some examples include using, say, software that can predict commodity prices by modeling different variables that we can know about our environment. So the price of corn is going to depend on the weather. The weather can be fed into a system, and we can also understand certain things, maybe investments in the agricultural sector. Maybe we have some information about tractor sales. Maybe we even know how much was spent on the seeds for corn in the past season, and so we're going to know how much might come up in the coming season, all fed into a model that can help us make decisions for the future. Okay, so those are different types of AI data analysis.